Welcome back. I'm Mr. Charlie, and this is SAT2 Physics Review. This is lesson 3, and today we're going to talk about dynamics. So last lesson, lesson 2, we talked about kinematics, the study of motion, and how acceleration, velocity, time, and distance are all related. So acceleration was the change in velocity, how fast you're speeding up or slowing down. Velocity was the change in position over time, how fast you're moving, and position was just your change in location. So we talked about these quantities and how they're related, how you can take an acceleration at a time and calculate the distance traveled, or how you can take the change in velocity and calculate the acceleration. And we had those 6 or 7 equations, right, that talked about all those things. But we didn't answer the important question of where accelerations come from, right? They don't just happen spontaneously. My marker doesn't just start zooming off into space from rest for no reason. I have to push it or throw it, right? So from your day-to-day life and intuition, you can already guess that the answer is probably going to be that forces cause accelerations, where forces are the quantity that describes how hard we push or pull something. And so today we're going to talk about Newton's, one of the most famous laws in physics, other than E equals mc squared. Sum of forces equals ma, or more frequently just F equals ma. And this is going to quantify how the force, or more accurately the sum of all the forces, equals the acceleration, or how it causes an acceleration. So by the end of this lesson, you'll understand why you can have some really improbable situations like this. I mean, this seems almost impossible, right? I took this picture in Zurich. This is 2 tiny rocks balancing on this huge rock in the middle. I mean, I can't imagine how long it took for the person who did this to get this to balance perfectly. But the point is, it's possible, right? And that's because all of the forces are perfectly balanced. There's no net force, so no acceleration. If there's no acceleration, no change in velocity. So the velocity starts out at 0, it stays at 0. So these are some of the ideas we're going to be talking about today. So Newton has 3 famous laws of motion. Forces and the 3 laws of motion all describe what causes objects to move and why they move in the way that they do. So dynamics is the study of motion, and so dynamics is frequently mostly the study of the equation F equals ma, which basically governs everything about how motion happens. Force is a vector. We use F as the symbol for force. Just like displacement, velocity, and acceleration. And the reason it's a vector is you'll see that it's very closely related to acceleration. So it has both a magnitude, a strength, which is measured in newtons, and also a direction. So you might say, I push or throw my eraser with a force of 3 newtons to the right, to my right. So Newton is the force. 1 Newton, I'll do a unit analysis here, equals a kilogram meter per second squared. So what this says is that a Newton is the force required to accelerate a 1 kilogram mass with an acceleration equal to 1 meter per second squared. So already we can see that where the F equals ma is going to come from, right? This is force, and kilogram measures mass, and meters per second squared measures acceleration. So you can already see where this is going to come from. And I'm going to talk about that too, how units can help you remember equations. So that brings us to the first law of motion, which is an object at rest will tend to remain at rest, and an object with a constant velocity will tend to maintain that constant velocity. So you could say that more precisely, or more condensed, as an object with a certain velocity will tend to maintain that certain velocity unless an unbalanced force acts upon it. So this even counts if the velocity is 0. So basically, it just says that objects have a natural tendency